At the 243rd meeting of the American Astronomical Society in New Orleans, some results were presented about the dark energy survey. What is dark energy? We know from measurements dating back to 1998 that the expansion of the universe is not slowing down, which is what was widely believed. The expansion is actually accelerating, and this gave rise to a Nobel Prize in 2011 to 3 winners who shared the prize for their contributions to that discovery. The discovery that the universe is expanding more rapidly, and that's attributed to something we call dark energy, which is an energy possessed by space itself. Dark energy is common throughout the whole universe. Unlike dark matter, which is actually a substance that's invisible, but it likes to be when normal matter is, because we think the two tend to go together, whereas dark energy is everywhere. It's a property of the universe as a whole. The early days of dark energy studies commenced with a very broad-minded attitude as to what this might be. One was quintessence, a fifth fundamental force of nature. Quintessence would be something that is actually basically evolves with time, whereas as time went on, it looked as though an alternative explanation was more likely to be correct, and that is, that dark energy behaved in a way that was consistent with something that Einstein introduced back in the 1920s, something called the cosmological constant, which was a fudging made to his equation of relativity, to make the universe not expand, because at the time he did this, he didn't know the universe was expanding. He called this his greatest blunder. The fact that he put his cosmological constant into the equation before it was discovered, even though it wasn't actually needed because the universe was expanding. But the fact the universe is expanding more rapidly suggests that there is actually a cosmological constant. And that was the other theory that had become more widely held as being reality. So what's the cosmological constant? Why is it different from quintessence? The fact is, quintessence doesn't evolve over time. It is something that is a property of space itself. It's a constant, but that means that space gets bigger. The amount of energy that the cosmological constant put in increases, so space gets bigger. And the energy increases as well in a sort of linear fashion, because it's a constant. The result of the dark energy survey actually suggests that is not quite the case. There is basically a property which we call the equational state. There's a number you can attach to that if dark energy is a cosmological constant. The equational state is exactly -1. But it is starting to look as though that is not quite the case. The answer looks like it might be something like -0.8 rather than -1. And this suggests it's not the cosmological constant, that there is in fact something that actually does evolve with time as the universe ages. So scientists say more evidence is needed for a conclusion.